In this video, we're gonna talk about sigma notation. So this is the sigma notation, and this is the symbol of sigma. It means the sum of. Now, this sigma has some properties. For example, if we have sigma from I equals 1 to n is a number bigger than 1, of ai plus bi, it can be minus also, so plus or minus, we are allowed to separate and write sigma from I equals 1 to n of ai alone plus or minus sigma of bi from I equals 1 to n alone. Another property that is helpful, so from I equals 1 to n, if we have a constant number multiplied by something in terms of I, so I'm gonna call it ai, then the k is not really related to I, so we can take it outside and we write k multiplied by sigma from I equals 1 to n of ai. Can I use a different index than I? Yes. We can use x, we can use t. So instead of the I, if you see t, that's fine. If we say we have k, that's fine. T, any letter, it's totally fine. For example, I have sigma from I equals to 1 till 5 of I. What is the meaning of this? It means I'm adding 1 plus, then I substitute after 1. So we start with I equals 1, and then I keep going 1 by 1 till I reach the number on top, which is the 5. So 1 plus 2 plus 3 plus 4 plus 5. And we can calculate this and get the final answer. Now, sigma of I starting 1 till 5 of, let's say we have I squared plus I cubed. Now for this one we can proceed in two ways. Either I apply the first property we have, when we have addition we can separate, or we can still do the following: replace I with 1 the first time, then we replace 2, we keep going 1 by 1 till we reach 5 squared plus 5 cubed, and then I calculate using calculator. Or if you want to separate, as I said, that's totally fine. So you can do sigma of I squared alone plus sigma of I cubed alone, then substitute instead of the I1 the first time, the second time 2, and so on to get the final answer. Now if I write sigma from I equals 1 to 5 of 3i plus 1, so again just substitute instead of I1, then 2, 3, 4 till we reach 5, and because you're using sigma, so we're doing addition. So I can write it in this way: 1 plus 1 plus 3, 2 plus 1 till I reach the 5. Instead of this, the 3 is not actually related directly to I, so we are allowed to take it out. So in this case I write 3 sigma from I equals 1 to 5 of I plus 1. Now we can write 3, and if I want to separate, since we have addition, we can do that. That's totally fine. Or you can write 3 and then 1 plus 1, 2 plus 1 till we reach 5 plus 1, and we calculate. So basically you can calculate or evaluate any sigma notation or expression in different ways. Now as a note, This is a very helpful note. Whenever we have sigma of, let's say, k equals 1 to 10 of the number 2, let's say. In this case, when I have an index but I don't see it here somewhere, this means that 2 is added to itself 10 times. From 1 to 10 it means 10 times. So it's like 2 plus 2 plus 2. Ten times. But instead of doing this, simply we can multiply 2 by 10 and get 20. So the main idea here is the following. Whenever there is an index but we don't see it here next to the constant number, then you are allowed to do this. Multiply directly the constant number with the number on top. I hope this was clear. In the next video we're gonna start with binomial expansion, and we need sigma notation, factorial notation, and combinations.